We're getting introduced to a topic called as logarithm differentiation. The best way to understand this, honestly, is to take up an example and understand it. So we have y is equal to x to the power of sin x. The question is, what is the best way to move forward? How do we differentiate this? Yes, direct differentiation looks okay. So using chain rule and all of that, we can do this. Not a bad idea, but a better version would be by applying log on both ends and moving forward. Applying log on both ends. So what do we end up with? We have log y is equal to log of x to the power of sin x. So a bit of rearrangement. And we have something else over here. So what is that something else I'm looking at? So let me write the formula before I apply it. So the clue is on the screen. Yes, it's been highlighted as well. So what is happening to the power? It's becoming a product of things. So we have the formula log of a to the power of n as n into log of a. On applying this particular expression will become what? Think of it. Think slowly. Aram se. Yes, sine of x into log of x. Now differentiating this is much easier because this is nothing but your product rule, right? So that's your product rule. Okay. So this makes it a lot easier to handle compared to what we have over here. Yes, this might not look to be that different, to be honest. In a sense, you might feel that the original question itself is easy to handle, but we're going to use logarithm differentiation in scenarios wherein knowing this or doing this makes it a lot easier. Okay. And after that, you differentiate and move forward. So that's the whole funda. Apply it and all of that. Okay. So this will be 1 by y into y prime is equal to so on and so forth. So let's not get into that. So we'll have an exclusive question to learn on this. Now, a lot of questions actually, not one question. So this is a write-up, so you guys can read. It's the same stuff. Okay, so it's a good write-up to begin with, and once we are using it, then this will make a lot of sense. Okay, I hope you guys write all of this. Now, this was an example of it being explicit. Things are very clear. This becomes very powerful. The method becomes very powerful in this case. That is your implicit case, right? Again, an example. So here we don't have y is equal to something. That's the whole point of explicit, right? Implicit and explicit. So in this implicit scenario, the log will help us a lot. So how do you handle this? We're going to substitute say x, not x, sorry, u as say y to the power of x, v as something, and w as something. That something is, I'm referring to this only. Now, the question will become, right, u plus v plus w is equal to a to the power of p. Now, if I differentiate both ends with respect to x, so the question turns out to be u prime plus v prime plus w prime is equal to a 0. Differentiation of a constant is 0. Now, where will you get the u prime, v prime, w prime? Because that's the question, right? End of it, we have to derive y prime, right? dy by dx is what we have to figure out. So we go back to what we substituted. We pick up those. So we have u, which is equal to y to the power of x. Then we apply log on both ends. And we saw this application. What happens over here? This turns out to be log of u is equal to x into log of y. And after that, we can move forward with the differentiation. Find u prime. So this by default will have y prime because of the expression what we have over here. Of course, it's not compulsory that we have to get an y prime from this. You'll get it from one of it, not an issue. One of it, all of it, doesn't matter. So you get an expression, then you solve for v prime, then you solve for w prime, and then substitute all of them. All into 1, or say first in this case. So this is first. And after that, a bit of simplification, we have the answer. Okay. So this is the introduction to both the scenarios. So in this scenario, we don't have a direct, sometimes we don't have. I think this we can do it. You guys will be able to do it directly. Wherever you have powers which are very difficult to handle, even in your explicit functions, make use of log. Again, it's not that you have to follow this method. It's a methodology. It's an introduction. Right? And with implicit, it's very clear. Making use of log is, or this methodology makes it a lot easier. We can do directly, not an issue, but yeah. Anyways, this is just a small introduction. You guys will get a detailed answering or use of the technique as and when we do more questions. And you will better appreciate what we have studied over here. Okay, for now, it might look a lot vague. Just take it, just write it. In time, it will make sense.